I was in high school. I had a physics teacher who happened to be a ham, and he got me interested in ham radio, among another person. He gave me a diagram for a 2-tube battery-operated receiver, and with that, I learned the code and read QST and got my license. In 1933, the depth of the Depression in Buffalo, New York, 25% of the men were unemployed, and fortunately for the hams in the city, Colonial Radio Corporation opened up a manufacturing plant, and if you had a ham license, you had a job. So I worked there something over 8 years. In 1936, I studied and got commercial radio telephone, radio telegraph licenses. Couldn't get a job, continued to work at the radio factory. And also in 1936, oddly enough, the control tower at the Buffalo Airport is going to go to radio control of aircraft. They had been using the telescope sort of thing with 3 lights, red, green, and orange or yellow. And they managed, the control tower managed to land two small planes at the same time, and they crashed, so they decided to go to radio. And it would have been a civil service job. The control tower operators would have to have a FCC license. So I went to night school to get some education in aircraft control operation. And one of the things that they had at the school was a teletypewriter, and it kind of fascinated me. So in 1948, a New York fellow managed to get an agreement with the Teletype Corporation that instead of junking the Model 12 teletype, hams could buy it for $50 plus shipping, and I got one of the Model 12 teletypes. I didn't have a terminal unit, of course, and that was the first thing I put together, a very simple unit. The only band we could use teletype on was the 2-meter band. That was the only band available for AFSK, RTTY. Another ham in Jersey, about 70 miles away, we had a system where the printers went on auto start, and we had a total of some 1,200 contacts over a year and a half time with teletype. You didn't have to be at the printer, but it made quite a bit of noise, and then you would get on and actually have the contact. So the initial terminal unit, so-called, was very simple, and when it appeared we were going to be allowed HF RTTY, I designed a terminal unit which appeared in QST in 1953. The advantage of this terminal unit, which by the way I designed while I was working at the Fort Monmouth Signal Corps lab, I had a supervisor who wasn't too happy about it because I was in the quartz crystal section of the laboratory. But he reasoned that the Army did use radio teletype at that time. So at least it was related to the needs of the Signal Corps. It turned out to be quite successful in that I had the availability of test equipment. I could make some tests, and between actually designing the components and then modifying them as I made some progress. It became quite popular because all of the components were readily available, and it worked quite well. Another article in QST was a circuit that showed how you could frequency shift a quartz crystal oscillator. So that went hand in hand with the high frequency teletype. That was useful then. I continued to do some work with filters because it turns out that with teletype especially, there's no error correction of any kind. And carriage return and line feed were two of the bit patterns, Baudot, the 5-bit pattern of Baudot. If you missed either one, then the printer would sit right there at the same time and overprint. So that was a serious problem with radio teletype. But anyway, I also invented then the variable frequency circuit using 4 quartz crystals. And I actually have the patent here. I'm going to put a display out on the table of some of the things that I've got in this bag here, which has a lot of rocks in it. Another terminal unit that I designed to use this patent that I had was to take the audio tones out of the receiver and up-convert them to a frequency of 4.3 megahertz. And then the crystal filter operated at 4.3 megahertz, I should say. I think I said kilohertz, megahertz. And at the time, some were using wide shift, 850 hertz wide. Others were using 100 and something. 170. And the advantage of that crystal filter was that you had a capacitor and you could actually tune to each of the frequencies, and it avoided some of the noise, especially in the 850 hertz shift, in the center of the band, because you had to have a bandwidth of a kilohertz with 850 hertz shift, and you got a signal here, you got a signal here, and you got noise in the middle. But this filter now sat at these two frequencies, so it decreased the problem of noise. One of the advantages I had at the Signal Corps Engineering Laboratories, I worked there from 2 weeks after Pearl Harbor until 1972. It's interesting because the 19th of December 1941, I got my final check at the radio factory. And that next Monday, 21st of December, I was in New Jersey in a rooming house and employed by the federal government. And as I said, 72 years. I spent 29 of the 30 years in the area of quartz crystals. During World War II, there was this very serious problem that there were no large manufacturers that produced crystals. There were companies like Wiley and on the East Coast, and Monitor Crystal on the West Coast, and a couple in the middle. But the requirements for crystals reached a stage that in 1943, 125 million quartz crystals were produced. And it took a lot of effort on the part of the federal government and the crystal branch. Here's a book, Crystal Clear: The Struggle for Reliable Communication Technology in World War II by Richard Thompson. Curiously, in 2008, I was at the radio club in New Jersey, and he gave a talk about this book that he had written, and he wrote in here to Marvin Bernstein, "Thanks so much for your service to the country and to the quartz crystal industry. All best regards, Richard Thompson." And in the list of names in the book, I am listed in this book. This will be one of the exhibits. So it's been kind of a remarkable life thing for me, in that I put in 38 years between 1943 and 1972, and had wonderful opportunities to learn about many subjects. I bought a sideband receiver and handed it up for a year and a half, and worked a lot of DX and got bored. So I went back to work. There's an ad in the paper for an electronic technician. I applied for it, and when I was interviewed, and I was asked how much money I was been making, and I mentioned the figure. This fellow says, "Oh, we only pay minimum wage." And I told him I wasn't really interested in the money. It was the fact that it was a different kind of environment, being in a manufacturing environment and not in a laboratory. So I was hired, and I assembled printers. It was a German-owned outfit, and they made a special printer that printed just digital, digit, not ASCII, and BCD and digit. And it was used by large-scale manufacturers. These big platform scales where trucks drive on or wait, and then whatever loaded, come out empty, it's wait again. And they had more than 60% of the market for that particular kind of scale. So the way it worked is I would go to the stock room, they give me a box with a bunch of parts, and I would assemble it, test it. Interestingly, they had a 24-hour run-in period where it ran all the 24 hours. You'd go back, take the printer out, retest it. So they were getting a lot of good quality information, but they weren't doing anything with it. So I put a recommendation in that the quality control group take the information we're producing from the tests and learn from it. And I did a few other stupid things like that. And one day the engineering manager came from another building, came over and he said, you shouldn't be working here. He said, I need a good technician. Come over, work for me, and you'll make more money. This was a thing. So I worked there at the Econ Corporation for 10 years, retired at 69, and made my fourth patent, the heat counter. The engineering manager came out one day. They had a patent on a unit called the heat, it was a device that plugs into a Xerox copy machine, and it was an attempt to control unused or unauthorized use of the copy machine. And he said we need a modern one, something with chips and things like that. I worked on some ideas, and in 90 days I came out with a workable model that we could plug into the Xerox machine, programmed it for a certain number of copies. When it got down to zero, let's shut the machine off and you couldn't use it anymore. It had to be reprogrammed. So I got a patent on that, and we went up to McGraw-Hill in New York with the marketing people and demonstrated it, and they wanted to know when they could have this thing, because now the fellow up there says it's exactly what we want. We then went to Xerox in Connecticut, showed it to them. They gave the company a $20,000 contract to finalize it, the mechanical design of it. And so I felt kind of happy about that. I want to talk a little bit about some of the things that I did during the period where, if you've ever heard of it, the Redstone rocket, ICBM, the Redstone Arsenal, Von Braun worked there developing rockets. Have a problem with old age. Let's see if I can talk. Anyway, in these two-stage rockets, they have a package developed by Jet Propulsion out of California that transmits back to the ground information on the acceleration, and because of the alpha shift, and information on the parameters of the rockets, the two-stage rockets, and it's done by frequency, by phase shift data over a single carrier frequency. But the problem was they needed a quartz crystal that was stable under the conditions that it experienced in the rocket. So they shipped us a huge shaker. Had two 1 kilowatt tubes, audio tubes, driving this shaker, and when the engineers at the Ford saw this thing, the weight of it, and the amount of energy that this shaker was going to use, the floor of the building wouldn't last. So they put down huge timbers. Well, first of all, they had to make a soundproof room because of the noise. Put big timbers down to distribute the weight and insulate mechanically the shaker from the floor. So anyway, we made the phase shift crystals and had been sending them to JPL. And then this was during the time of Eisenhower as president. He wanted, and by the way, there was something called a geophysical year, I think it was 1955-56. And he had advertised the fact that the United States was going to put up a satellite, the first Earth satellite, and it would be done by industry, not by the military. The Russians, of course, all that, their work was done by the military. Unhappily, the Russians got theirs up first because they simply used a two-stage rocket and a small transmitter in that second stage, and you put enough fuel and reduce the weight as much as possible and put that thing around the Earth. And that's the one you could actually see by visually without the use of the telescope. So Von Braun went to Eisenhower and said that Redstone could put a satellite up in 60 days, and that was Explorer 1, and we made the crystals for that. They needed the crystals as fast as possible. We made a group of 30 and carried them out to Jet Propulsion Lab. So I waited while they tested them, and one of the 30 failed. It actually broke. So they destroyed 29 and gave me the one that wasn't functioning. Took it back and took it apart, and we learned by just looking at it what had happened. We had then made another 30, but using a microscope, we visually looked for scratches on the surface of the quartz crystal, and it was the scratch that caused that crystal to fail. Another important thing that happened in the period around the mid-50s was that the Army was going to go to sideband radios. The normal crystal that was put together in millions in World War II, the frequency stability had to remain within 50 parts per million. After the war, the crystal specifications were tightened to 20 parts per million. With sideband, obviously, that won't work. So a whole new group of crystals had to be developed, glass enclosed crystals, and somewhere in there. Well, these are my rocks. Now this is the metal enclosed crystal. And this is the glass equivalent. So I'll put those out along with my rocks. So that was a whole new thing. We had to produce the TCXO, temperature compensated crystal oscillator. Aging was a big problem with quartz crystals. Just like we age, crystals age too. They were in the middle enclosed crystal, it was rather interesting. They all moved downward because of internal material somehow coming out of the metal and depositing on the surface of the crystal, which reduces the thickness. And with course, with the glass enclosed crystals, which by the way they're sealed in vacuum, which is a good trick. But that was one of the things we then they wanted some crystals that they could fire out of a 175 millimeter cannon. Now you're talking 15,000 Gs.
And they wanted to work.
Pardon?
They wanted to work after they came out.
Yeah, the object was we were going to have a package in the front of the projectile, and there was a timing system where it would be ejected, flaps would come out, and it would dive down into the ground. The front of the thing that went into the ground had a microphone. Antenna popped up, and now they could hear, this was for Vietnam, they could hear trucks, they could hear troops. That was
Task force
their whole. Well, Aberdeen Proving Ground in Maryland has the, I don't think I've brought it. I'll look, I may have brought it. The way they tested, they had a metal unit containing the components that were going to be tested. And they also had a small cylinder with a copper ball in there and a weight. And by measuring the deformation of the copper ball, they could determine the acceleration. In this case, that actually was a deceleration. They flew this thing out of a smooth barrel gun into a stack of lead, huge lead blocks. The lead in the first one, of course, melted and blew all over, so no one could observe this thing. But that soil around that system must have been horribly contaminated with lead. So the first crystals told me that they were destroyed. But by developing a stiffer support and being having a method of attaching the electrodes. Quartz crystals have two electrodes that couple the circuit to the mechanical piezoelectric effect in quartz. You bring these outside first through the supports and then through the pins. The biggest problem was how do you attach the supports to this thin quartz crystal. The oldest method was to use epoxy with silver in it. And this was another invention I made. It was the last one I made. Using electroplated nickel. It turns out I could electroplate nickel to a thickness of maybe a tenth of a thousandth of an inch, and it was incredibly strong. We made pull tests and all kinds of tests, and that worked. We were able to supply crystals that survived the gun launch. But as I say, it was tested simply by the deceleration, which was equivalent to that. So that was the end of the job with the fort. Does anybody have any questions? Maybe something that, yes.
I have a question, or not a question, a comment. That what you said there about the ground penetrators. I was at NKP Thailand where they ran all that stuff remotely, and I think the contractor, I think it was IBM, but I'm not sure with you. But all that stuff was Task Force Alpha, and they listened to all those ground penetrators that went through Vietnam and across Laos and every place.
Right.
But that brings back memories.
How many total patents do you hold?
4.
4.
Yeah. 3 at the fort, and then the one with Econ Corporation.
That's 4 more than most of us hold.
I'll tell you, some of the things I was involved with at the fort. Have you ever heard of GTOR? GTOR?
Yes,
Yeah, GTOR.
can use it.
You know what the G stands for? Marcel Golay. He was a
Golay.
French physicist. He worked at the fort as the chief physicist for the whole area, beginning in 1943. And in 1943, they had this problem with activity dips in crystals. Of course, crystals have to operate at the specifications call for -40 to +70 degrees C. You take some crystals, and all of a sudden, the activity goes right down, and as the temperature changes, it comes back again. So I was assigned to him, and he said what he wanted was to be able to look at the output of the quartz crystal as the temperature was changed, and he needed an oscilloscope, but there were no oscilloscopes working in the area of 2 to 20 megahertz. But what he suggested was to have an oscillator beat with the crystal frequency and down convert to the range of an oscilloscope, which had a range up to 100 kilohertz. And that worked out, and I worked with him for about 6 months, taking data. And he wound up by using the information I got from the tests to make a family of curves for the 2 directions of the quartz plate. Now, in those days, if you remember the FT-243, the plastic holder with the rubber gasket, the crystals were all either square or rectangular. Now, if you look at these new crystals, you find they're round, and that got rid of this problem. The problem was that there were harmonics of the vibration in the quartz crystal through the face length or width, and those had high frequency to temperature changes, and it was that resonance that interfered with the primary one that it caused its additional loss, mechanical loss. So it was great working for that. I mean, he was really a genius. It was really great. Anyway, I don't know how much time I've spent.
You got time?
15 minutes.
Anything else?
Anybody from the
I got a
radio?
question from the bridge. You're going to turn one of these off.
I don't have one.
I'll turn it off. Just for a second. Marvin, we do have a question from the bridge. Just a second. Okay, Marvin, this is a question from Alpha Foxtrot Alpha 4 Zulu Echo. Wonder what has happened to all the crystal manufacturers, and where do most of the crystals come from today?
Probably 95% of the crystal manufacturers during the World War II period have gone out of business. They've gone into other business. But some of them, International Crystal down in Florida, and Wiley, probably Wiley, I'm not even certain of that anymore. But some of the original companies that were in the crystal business are still there, but they can't compete with the foreign manufacturers because crystals are still handmade. And I've got some of the demonstration here. I'll show you. He started with a quartz crystal that originally came from Brazil. That was another thing, by the way. During the war, the crystals were so critical. The Germans knew we had tied all our radio equipment to crystal control, that they were sinking the ships that were bringing the quartz up from Brazil. By the way, Brazil at that time was the only place where natural quartz crystals were available. So one of the projects the branch got involved with was to grow quartz crystals. And I should have brought it. I had another demonstration, when I retired, they gave me a nice display of things I was involved with, and it showed both natural and a synthetic quartz crystal. So anyway, you buy a crystal now, unless you go to International Crystal or a few of the manufacturers that are left, they're made overseas. I think I've talked myself out of the job.
Good thing you aren't getting paid.
Oh, one last thing. I sent you 4 files, right? Did they go in? Are they in
We
the?
have them.
They're on the stick.
Okay. Dick Lambertson, the FA4QG, I know him well. Connie, AFA 3 VP out in Kansas. The fellow in Lakeland, Florida, AFA 2.
I can't remember his call either, Marvin.
Anyway, I got interested in running some tests. This was in 1933, I don't know. Yeah, 1993.
Yeah, what's 16?
Pactor and even Amtor and Packet came about. They were pretty much error-free, and so it gave me the opportunity to run some tests with these three stations to see what worked better as far as receiving the signals. And the proof of the pudding would be the speed at which this worked. And the funniest one is the one where I ran tests with Connie out in Kansas for more than a year on schedule, 9 o'clock in the morning and 9 o'clock in the evening, and plotted the results out in the form of a graph, which I hope I sent is one of those 4 files. It is. With Dick, he had his bulletin board, and at times I was pinging his bulletin board, getting a message from him and getting data that way. And I found some really interesting things. The proof of how well you can improve the performance of the digital, and it applies now to the new digital modes, is that you have to use the proper filter depending upon the bandwidth of the transmissions. For instance, when I go from the voice net in the morning, followed by the TRR net, I go from a bandwidth of 2.4 kilohertz to 300 hertz. That reduces my local noise by 4 S units. So anyway, some of the things I learned was that this I can get out and show you. The fellow at the draftsman at the Hecon Corporation could do artwork in this portion, in this way of a circuit board. And he did this for free because I fixed the CB radio.
What a nice thing.
Called Porter.
Of course, this is the old teletype printer. PRNet when we were using printers. So anyway, with that, I think I can call it a day. And I'll put I certainly appreciate it. I mean, at 99, give me a break.